This video is question 2 of our complex numbers revision, and in this first question they're talking to us about a complex number and its conjugate. They're telling us that z is in the form a plus bi, and we want to figure out what that z is. That means finding a and b. The first thing that I'm going to note is that since I also want to deal with the conjugate, and I've got z is a plus bi, that z conjugate is a minus bi. That's all the conjugate is, just change the sign of the imaginary part. And then I'm going to fill both z and z conjugate as best I can into the equation. And I'm going to do a little bit of tidying up here, some very basic algebra on the left-hand side to get the a's and b's out of the brackets, basically. And that's going to give me a much tidier 1a plus 7bi, and that's equal to the 1 minus 18i over 2 minus I. And then I want to maybe get rid of the fraction, so I'm going to look at this as complex division. Don't forget, for complex division, just multiply top and bottom by the conjugate. And just to specify there, it's the conjugate of the denominator that I'm multiplying by. So I'm now going to tidy up the right-hand side. And when I've tidied up, I'll be able to just pull out the a and the b fairly easily. So on the top, I'm going to get this result, 2 minus 36i plus I minus 18i squared. A bit more tidying up to do there in a second, but I'll get to that. And on the bottom, I've got 4 minus 2i plus 2i minus I squared. And the nice thing about multiplying by conjugates is that your denominator is always going to tidy up really nicely, and those two i's are going to cancel out. And of course, don't forget my key piece of information in complex numbers, which they have kindly reminded me of up the top, that I squared equals to minus 1. So here I have the top and bottom a bit more tidied up, and a little bit more. And then at this stage, then all I have to do is just divide by that 5. So don't forget where I was starting from with this. It wasn't just z, this was 4z minus 3z conjugate, which I had tidied up to 1a plus 7bi. And really it's the a and the b that I'm trying to get. So I'm going to equate the real parts and equate the imaginary parts. So 1a equals to 4, so happy with that because I need to know what a is, have it. I need to get the b as well. Okay, so 7b is minus 7, so that's pretty simple. B is equal to minus 1. And now I want to go back and make z, and z is 4 minus 1i. Just notice there that they said express it in the form a plus bi, so it's important that you put in that coefficient in front of the I to get your full marks. On we go to part B. They are talking about a complex number with modulus and argument given. These phrases, modulus and argument, they're key terms in the polar form of the complex number. Modulus is generally referred to as or in the polar form, and the argument of a complex number is the angle theta in the polar form. So they're making light work for me of setting up polar form here, and that's the first thing that I want to do. And actually, as I set it up, I'm not overly keen on mixed numbers. I'm going to write that down as an improper fraction. So I'm going to say w equals 27 over 8 times cos 2 pi over 3 plus I sine 2 pi over 3. And then they want me to use De Moivre's theorem. So I want to use that to find in polar form, and they want me to leave it in polar form so I don't have to convert back into rectangular form, the 3 complex cube roots of w. And then they're like, okay, right, if you didn't quite get that, that means find the 3 values of v, for which v cubed equals w. So let's write this line down first of all, so we can actually keep track of what it is that we need to do. And it's v that I want to find, so I want v by itself, and that means that v is the cubed root of w. So you can write it like that first if you want. But it's better to write it as v equals w to the power of a third, because then I've got my power that I can use when I'm applying my De Moivre's theorem. Okay, so I've got w here, and I want to put a power of a third in it. Remember, when you've got fraction powers in De Moivre, that's when I have to put in the n's. So if I want to put in my n's, n equals 0, n equals 1, n equals 2, I need to have an n in my polar form, but I don't have one at the minute. So that's where I put in my 2n pi. My plus n 360 if you like as well. So I'm going to go into this guy and put in plus 2n pi. And I'm doing that in the same line as introducing my power of a third. Okay, so now I want to apply that power. Remember, it'll be a power on the modulus, so it'll be a power in 27 over 8, and it'll get multiplied by the angles, or multiplied by the argument. And I don't need to get too fussed about simplifying out the brackets if I don't want to, because when I put in the n values, the calculator can take care of that. But I should probably sort out this 27 over 8 to the power of a third. It's a cubed root, that's why I like having it in the improper fraction form, because it's easy to see the cube roots of 27 and 8. But again, calculator can do the work for you. So that comes out as 3 over 2, and now I'm starting to put in my n values. So I've put in 0, I'm going to tidy it up. So for that first guy, I've got 3 over 2 cos 2 pi over 9 plus I sine 2 pi over 9. Don't forget, whatever you get as the argument for cos should be the exact same as the argument that comes after sine. On to n equals 1. Don't let this put you off. Again, calculator is going to take care of it. And you can type this bit into the calculator in full. Here's my next one, 3 over 2 cos 8 pi over 9 plus sine 8 pi over 9. And then into n equals 2. And I've got 3 over 2 cos 14 pi over 9 and sine 14 pi over 9. And there are my 3 solutions. And I got them by putting in those 3 values of n. And the 3 again comes from the power of 3 in the original part of the question. And I'm happy to leave those in polar form because they look nicer that way and they've instructed me to. And the last part of the question then, they are giving an arcane diagram. W is marked in. That's the W that we started off with at the very beginning. Back up here are 27 over 8, polar form complex number. And they want us to show our solutions to part 1 and write down the equation of the curve on which all 3 roots lie. So if we have a look at our 3 solutions up here, you'll see that they're written in terms of pi, and it's probably a little bit easier for us if we convert these into degrees at this stage. So for the first guy, the angle is 40. Pretty much the same for V2, but the angle changes to 160. And my third solution had an angle of 280. And you can actually see that the difference between the angles remains constant, so it's plus 120 plus 120. And that's going to be reflected in our diagram in a moment as well. So when it comes to actually putting these onto my diagram, I'm going to be given great assistance by my compass and my protractor, because they're going to allow me to be nice and accurate about it. I'm going to start off by just identifying the origin. And then what I'm going to do in each case is I'm going to come out a distance of 3 over 2 or 1.5 from the origin. And I'm going to rotate from the positive sense of the real axis by the angle identified in the polar form. So I'm going to come out to 1.5 and then I'm going to rotate by 40 degrees. It's probably easier to mark in the 40 degrees first of all. So there's my 40 degrees. I've just put a little dash there on my diagram to identify it. In fact, probably even better to just draw in a line along that angle. I'm going to measure 1.5 with my compass so I can figure out exactly where on that line I'm meant to land. And there's V1, my first solution. Back to the origin, this time measuring an angle of 160. And again, I'll just connect that back to the origin to make it clear for myself. I haven't altered the radius of my compass, so I'll just come and I'll draw another little arc on that line this time. And that's going to identify where V2 is located. And then finally I want to mark in V3. Now it's 280 degrees around, which is a bit awkward on the compass, but if it's 280 degrees this way, well then it must be 80 degrees this way to make up the 360. So I'm just going to measure around 80 degrees. And there I am joining it up. And then back to the compass to make sure that I'm going the right distance out. So I'm going for the right modulus of 1.5. And there's V3. So I've marked in 3 roots. And now I want to identify the curve on which they lie. And actually you might be able to see here, since they're all the same distance from the origin, you actually already see those curves going in, they're actually lying on a circle. So I've drawn in the circle so we can see it. And don't forget, of course, the equation of a circle is x minus h squared plus y minus k squared equals r squared. So my center is the hk, that's the 0, 0. And my radius is just the modulus. So there's the equation of my circle. And just to tidy it up then, I can say x squared plus y squared equals 9 over 4.